Good morning. Today we are going to discuss that is clamping circuit. Under linear and non-linear wave shaping circuit, we have to study clipping and clamping. Clipping circuit we have already studied, that is positive clipping, negative clipping and biased clipping. Under clamping circuit also we have to study positive clamping, negative clamping, biased clamping. What do you mean by a clamping circuit or clamper? Clamping circuit is basically a level shifting circuit or DC restorer. In some cases, we had to add or subtract a DC voltage to a given waveform without changing its shape. In the case of clipping circuit, the wave shape is altered, but in the case of clamping circuit, the entire waveform that will appear at the output, peak to peak voltage remains same in the clamping circuit. When we are applying 20 volt peak to peak at the input side, after the clamping, the output voltage will remain at 20 volt itself. Circuit used for this purpose is called clamping circuit. In the case of clamping circuit, the main component used is the diode, and for the DC shift or DC level storage, capacitor is incorporated in the circuit. A circuit that places either the positive or negative peak of a signal at a desired DC level is known as a clamping circuit. A clamping circuit introduces or restore a DC level to an AC signal. Thus, a clamping circuit is also known as DC restorer or DC reinserted or baseline stabilizer or level shifter. This is the basic form of clamping. Clamping is broadly classified into two types, that is positive clamping and a negative clamping. In the case of positive clamping, the input waveform applied is shifted, entire waveform is shifted to the positive direction above the reference line or DC line. And under negative clamping, the entire waveform is shifted downward, that is the entire waveform will shifted downwards. In the case of clamping, the y-axis coordinates, that is the DC level only is shifted. The peak to peak voltage remains same. Input voltage we are applied is at the positive peak Vmax and the negative peak minus Vmax. The peak to peak voltage is 2 Vmax. Under positive clamper, maximum peak will appear at 2 Vmax, and the zero axis we will get Vmax, and at the minus Vmax we will get the zero voltage. This waveform is obtained under the condition that if you are using an ideal diode. When we are using a diode with cut-in voltage 0.7, the entire wave shape that will shifted to, that is at the below the zero level, minus 0.7 will remain, and the peak to peak maximum, suppose we are applying 10 volt peak to peak signal, means maximum voltage is 19.3 and the minimum minus voltage is minus 0.7 and the middle point will become 9.3. Positive clamping occurs when negative peaks rise or clamp to ground or to the zero level, or it pushes, that I already said that, or complete waveform is shifted upward in the case of positive clamping, and complete waveform is shifted downward in the case of negative clamping. Under clamping operation, we have to study positive clamping as well as negative clamping. In the case of positive clamping, the circuit consists of, that is a capacitor, and in the case of positive clamping, diode's negative terminal is connected across the output. So negative part will connected to the capacitor and the positive part is grounded. This is the circuit diagram of positive clamp. Output is taken across the diode. We can now check the working of positive clamping circuit. During positive half cycle of the input, positive half input signal we are applying a sinusoidal signal. Sinusoidal signal has two half cycle. This is upward portion is the positive half cycle, is the positive voltage, and downward cycle is the negative half cycle. We are applying the signal maximum voltage, that is Vm, maximum positive peak is Vm, maximum negative peak is minus Vm, and the DC line is 0 voltage. Under reference voltage is 0. Peak to peak voltage of this waveform is 2 Vm. Suppose you are applying the positive peak voltage is 10 volt and negative peak voltage is minus 10 volt. The peak to peak voltage of this signal is 20 volt. We are applying 20 volt signal to the positive clamping circuit. What will happen? That will check. And during the positive half cycle of the input signal, sinusoidal signal, the diode becomes reverse biased, and now diode becomes reverse biased means diode will become open circuit. There is no action takes place at the output. During the first, that will also observed in the simulation experiment also. Capacitor takes time to charge and discharge. For the first half cycle, you didn't get the output as clamped. After that, when the capacitor charged to the peak value, the clamping operation continues. During the negative half cycle of the input, what will happen? During negative half cycle of the input voltage, this is the circuit diagram of positive clamper. Negative half cycle of the input signal, the diode is forward biased. Diode is forward biased means negative is connected to negative and positive is connected to positive. Diode is forward biased and diode conducts. Conduction current flows through the diode. So the capacitor charges to peak voltage, that is minus Vm. This is the peak voltage Vm. During the negative half cycle, diode is forward biased and the diode conducts. Diode conducts means the capacitor has the property that if it is gets the DC voltage, it charges to the maximum voltage of the DC input. So it charges to the maximum, that is Vm voltage. During the negative half cycle of the input voltage, capacitor maximum charges to Vm voltage. And we will check the output of the this circuit. At this point, we can find the output voltage, capacitor voltage at this end. That is the capacitor voltage is, that is Vm. This is a plus minus, so the potential is Vm, and the terminal is, this is minus and plus, so the cut-in voltage of the diode is V gamma or cut-in voltage. V gamma here represents the cut-in voltage of the diode. So the output voltage of the circuit is the, considering the KVL of this loop, output voltage is equal to input voltage plus capacitor voltage. So in the case of positive clamping, during the negative half cycle, capacitor charges to peak voltage Vm. So the from the output side, the direction of capacitor voltage is current flow direction is the higher potential to lower potential. So at the output peak, we are getting Vm volt, and from this side, output side, the polarity of diode is negative and positive. So the cut-in voltage, we can get it as minus V gamma or minus 0.7. So the output voltage is equal to V in plus capacitor voltage. So the expression of output voltage will become input voltage plus Vm voltage minus cut-in voltage of the diode. This is the output voltage equation of positive clamper. Under positive clamping, we can apply the input sinusoidal signal, that is a sinusoidal signal. This is the zero potential, this is the Vm potential, and this is the minus Vm potential. I already said that we are applying Vm as 10 volt minus Vm as minus 10 volt. During when the input voltage becomes zero, what will happen? We can analyze this clamping operation at three extreme points. That is the zero starting point and the maximum point and the minimum point. Input voltage, we can discuss the three case. That is the case 1, that is when input voltage is 0. When input Vin equal to 0, maximum only 3 points we are considering: minimum point, maximum point, maximum point, and average point. Vin equal to 0, what will happen to the output voltage? When Vin equal to 0, Vout equal to 0 plus Vm. Vm here is 10 minus 0.7. What will be the output at V in equal to 0? When V in equal to 0, output will obtained at 9.3 volt. Similarly, we can analyze when V in equal to Vm and V in equal to minus Vm. When V in equal to Vm, we will get output voltage. That is the second case. Output voltage V in equal to Vm, that is 10 volt, output voltage equal to 19.4 volt. Here the cut-in voltage, in some textbooks, the cut-in voltage is expressed as 0.7, or in some textbooks that is expressed in 0.7. We can use until otherwise specified in the question paper, we can use either 0.7, both are correct, 0.7 or 0.6 knee voltage or cut-in voltage of the diode. When the input voltage is 0, output becomes at almost 9.3 or 9.4 volt. When V in equal to maximum peak, output will, we can get when you are substituting the value in the above equation 1, 19.3 volt, and V in equal to minus 10, output will become minus 0.6. We can draw the transfer characteristics, that is V in with the V out on the XY plotter. In the x-axis, we are trying to plot the input value, and the y-axis, we are trying to plot the output value. When V in equal to 0, the output will, y-axis output will become 9.4. When the V in become maximum, that is 10 volt, V out will become 19.4, and V in equal to minus 10, output will become minus 0.6. So the positive clamper circuit diagram and the transfer characteristics is as shown in the figure. Likewise, we can explain the operation of negative clamping also. This is the operation of positive clamper. In the case of negative clamper, what will happen? The diode direction is reversed. This is the circuit diagram of a negative clamper. During the positive half cycle, diode conducts and the capacitor charges. This is the conduction cycle. So the capacitor charges to from the output side, we can get the capacitor voltages minus plus means minus Vm. The diode's direction is plus minus, so the cut-in voltage is 0.6. Then output voltage is equal to, in the similar case, we are already detailed explanation about, we done the detailed explanation done on the positive clamper. Likewise, negative clamper can also be calculated. Output voltage at three cases: when Vin equal to 0 volt, when Vin equal to maximum volt, and when Vin equal to minimum, that is minimum peak minus Vm. Clamping is just the entire waveform is shifted upward or downward. When we are applying a biasing voltage, what will happen? The biasing voltage addition is also incorporated. So the capacitor voltage from the this is the positive clamper circuit. When the biasing voltage is 3 voltage is applied. So the capacitor voltage, the biasing potential will also be added. Likewise, when the biasing is reversed, the battery supply has to be reversed. We are applying minus 3 volts. So the capacitor voltage from the output side, we are getting Vm minus 0.6 minus 3. These 2 volt diode drop and voltage source are in series, so they get added. So the entire wave shape, we are from the entire wave positive clamper circuit, we are subtracting minus 3 voltage. In the case of positive clamper, clamping at minus 3 volt, and in the case of positive clamper clamping at plus 3 volt, the entire waveform you have to add plus 3 volt. So the peak to peak voltage will remain same. 22.4 minus 2.4 is the, we are applied a total voltage of 20 volt peak to peak.